Let's find the volume of a solid of revolution obtained by rotating a region bounded by the parabola y equal to 2x minus x squared, the x-axis, and then take this region and rotate it about the y-axis. So we're going to need several things. First, let's find the x-intercepts of the parabola. We're going to take the parabola on the right-hand side, 2x minus x squared, set it equal to 0, factor out an x. X times 2 minus x is 0, so x equals to 0 or x equal to 2. We're also going to need, in the solution, to solve for x in terms of y. So we are going to take the original parabola, 2x minus x squared. Let's move everything with the x over to the left and y to the right. X squared minus 2x is equal to minus y. By completing the square, that is adding 1 to both sides, we'll be able to solve for x. So if I add 1 here, I'm going to also add 1 on the right. X squared minus 2x plus 1 is x minus 1 squared equals to, let's write it as 1 minus y. Take square root of both sides. X minus 1 is equal to plus or minus the square root of 1 minus y. X is equal to 1 plus or minus the square root of 1 minus y. Now, we're going to use in this problem what we call the washer disk method in order to find the volume of a solid of revolution. Now, in a later video, I'm going to come back to the very same problem and solve it using a different technique called the shell method. You should look at that video and decide which method is easier for you. In my opinion, the shell method is easier than the washer method for this problem, but nevertheless both give us some idea of how to set up integrals to express volumes of solids of revolution. So let's graph this region now. It's not difficult to graph it at all with just the couple of points we have. It intersects, the parabola intersects the x-axis at 0 and at 2. The x-coordinate of the vertex is halfway at 1. Plugging it into a parabola, 2 minus 1 is also 1. So our vertex is at 1, 1. It comes down like this, it comes down like that, and then the x-axis cuts it off. And this is the region that we'll be rotating. Remember that this right-hand side of our parabola is x equal to 1 plus the square root of 1 minus y. And the left-hand side of the parabola is x equal to 1 minus the square root of 1 minus y. That's why we needed it. We needed to solve, there's not a single function that will give us x as a function of y for this parabola. We need two. We need one for the left, one for the right. Now select a y, keep track of this horizontal slice of the area. 180 degrees into the rotation, it ends up over here on the other side of the y-axis, and the full rotation gives us this washer. And the problem comes down to finding or expressing the area of this washer as a function of y. Once we do it, we then will be able to integrate, set up the integral, and find the volume. So recall, when we have a washer with this inner radius little r and the big radius here of the big circle big R, the formula for the area between the circles is pi big R squared minus pi little r squared, or pi times big R squared minus little r squared. We need to express big R and little r as functions of y. So for any y, the center of our washer here is on the y-axis, and the big R is from that center, from the y-axis, over to here, this point that I'm drawing right now. And that's exactly the x-coordinate on the right side of the parabola, which is 1 plus the square root of 1 minus y. And similarly, the small radius is up to here, and the distance from the y-axis to here to give us the small radius is x equals 1 minus square root of 1 minus y, which is the x-coordinate of the left part of the parabola. And once we have that, the integral is pi times the integral 0 to 1. That's where that's for all the y values where we get our washers. Big radius, 1 plus the square root of 1 minus y squared. minus little radius squared, 1 minus square root of 1 minus y squared. And this is integrated with respect to y. Let's go ahead and simplify this. This is pi times the integral from 0 to 1. The first integral gives us 1 plus 2 times the square root of 1 minus y plus 1 minus y. Let me put it in parentheses like that. And then we're subtracting from that 1 minus 2 times the square root of 1 minus y, and then plus 1 minus y dy. And notice a couple of things. The 1's cancel. This one cancels with this one, and then 1 minus y minus 1 minus y also cancel. And what we have are 2 square root of 1 minus y minus a minus 2 square root of 1 minus y. It gives us 4 pi times the integral from 0 to 1, the square root of 1 minus y, or 1 minus y to the 1/2 power dy. And this is an easy integral. We get 4 pi. The integral of 1 minus y to the 1/2 is minus 2/3 times 1 minus y to the 3/2, and this is evaluated from 0 to 1. Plugging in 1 for y, we get 0, so this is 0, minus 4 pi times negative 2/3 would be minus 8 pi over 3, and then times 1, so the final answer is 8 pi over 3. For more videos